Okay, this is our ECE 2031 project demo. A little introduction to our peripheral. So our task was to design a peripheral that interfaces with the ADC chip, which was the LTC 2308, so that users are able to trigger and receive analog to digital conversions from SCASM applications. And then on top of that, we were tasked with demonstrating an application of the peripheral that we built. So to the right here is a higher level flowchart showing our peripheral's functionality. So we're able to write to our peripheral to configure the ADC, and then that'll let us select channels and start a conversion. And then we're also able to read from the peripheral to get our digital conversion result back. So a little bit about using our peripheral. So users have the ability to write programs that can interface with our peripheral via memory mapped I/O, and we chose the address 192. And then from that, you're able to read values from the ADC, which will be single-ended 12-bit resolution. And then you're also able to write configuration commands to the ADC, which will also be 12-bit values. So writing via our peripheral can be used to configure the channel that the ADC will sample readings from, and the table on the right shows the channel configurations. And then reading via our peripheral is guaranteed to give you valid data samples from whichever configured channel you selected.
So here's a video of our application in action to demonstrate our peripheral capabilities. At a high level, it's just a guessing game where you input a target value with switches, and then you try to hone in on this target using the potentiometer knobs. So you'll see right here, this is me inputting my target value using the switches, and then I submit this pattern as the one I want to try to aim for using the right potentiometer knob, which is currently configured to read from channel 2. And then when I put this last switch down, it inputs my guess, and you'll see that's how far off I am from the target value right now with my left potentiometer knob. And then so this is the main portion of the game. It's just submitting guesses, seeing how far off you are, and then trying to hone in using the left potentiometer knob, which is configured to read from channel 0. This is just the brunt of the game, trying to hone in this target. I believe after this next one that I hit my goal, and you'll see it took me 6 tries, and then boom, this is the win stage. And then you'll see to restart the game, I have to turn the right potentiometer knob to FFF and back down close to 0, and then I'm ready to play again. And I get to input a new pattern and try once more. I'll give one more run through this game just to show it in action a little bit. That's me spitting the pattern. And then again, when I put this last switch down to make my first guess, so I put it down close to 0. And so basically what that does is allow me to hone in on this target on my second guess pretty easily. I just have to get close to that number that was displayed as the offset. And then this will be my second guess, and you'll see that's the win condition. And this is our application. Thank you.